Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 4E. Myself, Priyanshi Goyal. And this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the ninth International Congress on Information and Communication Technology, ICICT 2024, London, UK. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2024, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd Feb 2024. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 7 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for questions and answers. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we get started, I would like to introduce you all to our chair for this session. I'm sorry, to the chairs for this session. Professor Ika Nurul Kumari and Dr. Deepak Mane. Professor Ika Nurul Kumari is a lecturer and associate professor at the Department of Management, Universities Muhammad, Muhammadiyah Yogyakarta, Indonesia, currently establishing a research collaboration on the topic of strategies of human resource development. Dr. Deepak Mane is currently working as Associate Professor at Vishwakarma Institute of Technology, Pune, India. He has 17 years of teaching experience and has written books on machine learning, fundamentals of programming languages, and principles of programming languages for computer and IT students. His main research work focuses on machine learning, deep learning, and supervised clustering. Ma'am, sir, I invite you to chair the session. Thank you for joining us. I will request you to share any welcome remarks you would like to share with the participants.
Okay, thank you, Priyanshi, for your nice introduction. And it's a proud moment as a session chair for this ICICT 2024 International Conference. And I eagerly waiting for the presentations. Yeah, thank you. Yeah, we can start now.
Okay,
Thank you,
greeting
sir.
from Indonesia. Please, for all participants.
Thank you, sir. Thank you, ma'am. With this, I would like to start with the presentations for today. First of all, I would like to invite ma'am uh, Umayma Lifandili for her paper presentation titled Baruta Feature Selection Applied to Classification Algorithms for Intrusion Detection. Ma'am, do we have you here with us?
Hello, yes, answering my name.
Hello?
Hello, hello, can you hear me?
Yes, your voice is very, like it's not audible properly.
Okay, and now?
Yes, but it's better. So, I've
Okay,
stopped
I'm
the
sharing my
presentation.
screen.
You can present your paper.
Okay.
Yes, it's visible.
Yes, can you see?
Yes, visible.
Okay, let's get started.
Thank you.
Hello, everyone. I'm delighted to welcome you to this presentation dedicated to my study entitled Borita Future Selection Applied to Classification Algorithms for Intrusion Detection. In this work, we explore the effectiveness of the Borita algorithm in the field of intrusion detection, a crucial area of cybersecurity. Intrusion detection is essential to protect computer systems against malicious attacks, and the choice of relevant feature is a key aspect of this task. Our study aims to evaluate how the Borita feature selection approach can improve the performance of classification algorithms used in this context. We conducted extensive experiments using well-established intrusion detection datasets and compared the results with other feature selection methods. The results provide valuable insight into the effectiveness of Borita and its potential to improve intrusion detection in modern IT environments. This plan begins with an introduction that sets the context of the study and presents the research objectives. It then focuses on explaining the Borita algorithm, detailing its operation and application in future selection. And next section explore the various classification algorithms used in this study, highlighting their role in intrusion detection. The proposed system is then presented, describing how the Borita algorithm is combined with classification algorithms to enhance intrusion detection, and future researchers' perspectives and are discussed to open new avenues of inquiry and improve the study. Finally, the conclusion summarizes the main findings of the study and cloud computing service delivery paradigm enables users to access computing resources such as servers, applications, storage, and networks via the internet. The paradigm is increasingly vital for companies of all sizes due to its numerous benefits. These benefits include flexibility and scalability, as businesses can adjust their IT resources to match their needs without the need to invest in and manage their own infrastructure, resulting in cost saving. Additionally, cloud computing provides access to cutting-edge technologies like artificial intelligence and machine learning without requiring upfront infrastructure investments. Users can store data, including documents, photos, and videos, as well as host applications such as accounting and human resources management software using cloud computing infrastructure. However, attackers continuously seek new ways to undermine the security of data stored in the cloud, given that cloud computing is a rapidly evolving technology. Primary security concerns with cloud computing include unauthorized access, data theft, denial of service (DDoS) attacks, and malicious software intrusion malware. Attackers may also employ social engineering tactics to deceive users into divulging private information. To address these security challenges, machine learning and deep learning, both artificial intelligence techniques, can be used to enhance intrusion detection. Machine learning enables computer systems to learn from data without explicit programming, allowing for the detection of anomalies that may indicate attacks. And deep learning, a type of machine learning, leverage artificial neural network inspired by the human brain to learn complex patterns in data. Various machine learning and deep learning techniques can be employed for intrusion detection, including detecting SQL injection attacks, denial of service attacks, and malware attacks. In this study, the Borita algorithm is used to select relevant attributes attributes from the data sets, identifying the most important variable, even if they are correlated. And the Borita is chosen for its ability to identify important variable and its robustness to noise compared to other variable selection algorithms. The process of selecting the most pertinent and useful characteristics from gathered data in order to train efficient intrusion models is known as future selection in intrusion, reducing the number of redundant, noisy, or informative features while keeping those necessary for identifying suspicious or malicious activities in the aim to reducing the dimensionality of the data. And the importance of feature selection is in intrusion detection consists of promptings. By selecting the most relevant features, the performance of intrusion detection models can be significantly enhanced, enabling more precise and effective detection of malicious activities while reducing complexity and data dimensionality. This simplification of modeling leads to more efficient intrusion detection algorithms that are less prone to overfitting and contribute to the optimization of computing resources, such as memory and processing power during model training and deployment. Furthermore, focusing on a restricted set of important features makes intrusion detection models more interpretable, facilitating understanding of results and decision made by the detection systems. Feature selection is a critical step in many machine learning workflows as it aims to streamline the model building process by identifying and retaining only the most relevant features while discarding unnecessary ones. Introduced in 2010, Borita is an algorithm that offers an intelligent approach to automate feature selection from a given dataset. Borita operates on two innovative concepts. Firstly, it employs shadow features, which are duplicate variables created from the original ones, but with added noise. This technique enables Borita to discern important variables even when they are correlated with others, as the noise complicates the distinction between the original and shadow variables. Borita trains a classifier using both original and shadow variables, gradually removing original variables while evaluating the impact on classifier performance. And secondly, Borita leverages the binomial distribution to access the likelihood that the observed difference in classifier performance between original and shadow features is due to chance. A low probability indicates that the original variable significantly contributes to the model's predictive power. And by generating shadow feature for each original variable and using the binomial distribution to evaluate performance, Borita effectively identify crucial variables correlated one. This makes it a robust tool for future selection, essential for enhancing model accuracy and interpretability. Classification in the context of machine learning involves categorizing data into predefined classes or categories based on its feature or attributes. It is a supervised learning
This is a
task.
gentle 10 minutes reminder.
Hello,
Hello,
excuse me,
MS is giving you 10 minutes reminder.
I don't hear you well. Can you repeat, please?
Ma'am, you have completed 10 minutes. You have 2 minutes left.
Okay. Okay, can you move to proposed system? That's important part. Okay, in this section, we outline our proposed approach, completion phases. The first phase involves attribute selection using the Bolt algorithm, while the second phase focuses on indication detection. The objective is to evaluate the systems to integrate symbolic with classifier to enhance classifier performance for improved outlier detection results. Additionally, employing multiple classifiers aims to ensure enhanced outcomes across various classifiers when combined with Borita. Let's explain the first part. The initial stage of our process involves data preprocessing, where we clean and prepare the dataset for analysis. Following this, we partition the dataset into two subsets, one for training the model and the other for testing its performance. Next, we use the Borita algorithm to analyze the dataset. Borita is particularly adept at identifying significant variables, even when accuracy are present, and it's well suited for handling large datasets. Its main function is to identify essential variables that may have been overlooked by other feature selection methods. And the second part of the process use the list of features identified by Borita. This involves reducing the dataset based on the selected attributes provided by Borita, and the newly transformed dataset is then feed in multiple classifiers to observe and compare the results obtained with and without Borita. And this comparison allows us to analyze the impact of Borita on the
Sorry to interrupt, ma'am.
performance.
Uh, may I
Hello?
request you? Yes, sorry to interrupt. Can you please conclude the presentation as you have crossed the 12 minutes mark?
Okay. I close it.
Okay. Thank you, ma'am. Are there any questions?
Okay, I have one question regarding your proposed method. Okay, can you elaborate something what you include in Baroda feature selection or in intrusion detection? What is your contribution? Please, okay, tell me more on that.
Yes. Firstly, I have already conducted simulation of this approach, but I intend to publish it in a journal article, which we also include analysis and discussions. Okay.
Okay.
And this paper conference that include only the approach. We
So,
define the approach in this paper, but the simulation and implementation of this approach are covered by the journal article.
okay, how you compare your result with existing?
Yes. Okay. Yes, our study includes a detailed comparison with other similar studies. presented in the form of table in our journal article. However, in this conference paper presented today, we focused on defining our approach.
Okay.
Okay, and while there are indeed other papers exploring feature selection techniques in intrusion detections, but our approach stands out for several reasons. Unlike traditional methods, Borita excels in handling complex datasets and capturing nonlinear relationships and managing high dimensional data.
Okay. Thank you.
Thank you.
Thank you, ma'am. Moving forward, I would like to invite Sir S.M. Mizanur Rahman to kindly present his paper titled Design of a Solar-Powered Robotic System for Reaching and Grasping Assistance. Sir, do we have you here with us?
Yes, I am with you. Just give me a minute to open my computer and to share it with you. Okay.
Sure.
Yes. Okay, so do you see my screen?
Yes, your screen is visible.
Okay, thank you. So now, okay, now please confirm me that you see my screen, right?
Yes, your screen is visible and you are audible. You may start the presentation.
Okay, thank you very much. Thank you. So okay, so I will start my presentation. So the title is Design of a Solar-Powered Robotic System for Reaching and Grasping Assistance. My name is Mizanur Rahman. I am an assistant professor of mechanical engineering at the Pennsylvania State University on its Scranton campus in Pennsylvania, USA. So. So background and motivation. So then actually reaching and grasping assistance tools can greatly enhance the quality of life of old, sick, and disabled people. The tools should be convenient for use and ergonomically appropriate. And also we believe that powered tools may outperform manual tools. However, powering power tools is an issue, especially in remote areas. We believe that solar power may play a significant role in this situation. So, however, we do not see any good reaching and assistance tools in the literature that can use the solar power to power the electronics of the tool. And also, we think that the reaching and grasping assistance are mostly manual. These are not powered by any electronics mechanism. So considering this background and motivation, so our objective is to propose the ergonomic design of a solar-powered reaching and grasping assistance tool for old, sick, and disabled people in remote areas, and also to evaluate the design experimentally. Anyway, so it is proposed for the old, sick, and disabled people in remote areas, but anyone can use it. But it is especially designed for the old, sick, and disabled people, considering the power crisis or power limitation in the remote areas of different countries. So this is the proposed design of the tool, and you see that I think so. In the left side, so it shows the entire design. So at the top of the design, we have the red part. The red part, it is the gripper that can grip the object that an old person can grip for his or her own benefit. So it is automated by a motor and with a gear mechanism. And this motor is actually controlled by a potentiometer, the black part at the in the uh, other side. Black part, this is a potentiometer. Then the potentiometer can be used to control the movement of the motor with the gear, and the motor and the gear can control the opening and closing of the grippers. And we have different types of grippers in the right side of my slide. So for example, this is one type of gripper, there is another type of gripper. So we can exchange the different types of grippers that will give us flexibility to use it for different types of objects. And also the blue part, it is a solar panel and this solar panel will actually power the electronics. For example, the Arduino board for the motor operation, and inside the I think that power the solar panel. So there is a place location where we can accommodate the Arduino board and other electronics. So that can be accommodated inside this inside this power solar panel. So this is our design, and we analyze the design using SolidWorks for different parameters, characteristics. For example, this is a displacement test in the SolidWorks that can help us understand how the device will undergo or experience a load of 10 pound or about 5 kilogram. If we want to pick an object of about 4.5 kilogram or 10 pounds, so then how it will react, or what will be the displacement or plastic deformation of the system. And we see that it is negligible. And also this diagram shows the stress analysis. If we want to pick an object of 10 pound using this design, then how the stress will generate and whether it is harmful or not. And we can analyze it using the stress strain diagram. And based on the analysis using the stress strain diagram, we think that the stress is not so severe. And also we can analyze the strain using the stress strain diagram, and we can see that it is not also so severe. So our design is acceptable for holding, for gripping an object of maximum 10 pound. But it can be used to I think manipulate objects that are more than 10 pound. But if we consider a 10 pound object, 10 pound weight object, then it will be fine, or less than 10 pound. So then after that, when we got favorable results from our SolidWorks analysis of the design, then based on the design, we made the prototype. And this is the prototype. Here you see that we made the prototype using 3D printing. We 3D printed the body structure of our device, and we used the motor, the Arduino board, and other electronics, and also the potentiometer. So then our prototype was ready to do the experiment to test the performance of the system. So then we did some component level test. So in the component level test, what we did, we actually created the motion. For example, you see that it is a component level test. Here we used different types of motor, a small motor, servo motor, and servo motor was connected to an Arduino board. And also we used a potentiometer, rotary potentiometer with the Arduino board, and then we connected the Arduino board with the computer, and we use the code to run the motor through the use of the to control the motor by the rotation of the rotary potentiometer. So then what we did, the subject actually rotated the potentiometer and we observed whether the motor was rotating following the direction of the rotation of the potentiometer or not. So our observation, based on our observation, we found that so actually the motor was tracking the movement of the potentiometer. That means when we moved the potentiometer in the clockwise direction, and then also the motor also rotated in the clockwise direction, and when we did the opposite, for example, we rotated the potentiometer in the counterclockwise direction, and also the motor rotated in the counterclockwise direction, and the speed of the movement and the direction of the movement were agreeable between these two, between the controller and the controlled motor. So based on our results, we were happy that our potentiometer was working properly, and that was able to control the movement of the motor according to the direction and speed of the user. So after that, we did the experimental evaluation of the performance. So we asked different human subjects to operate the device to pick and place different objects. So this picture shows that a human subject opens and closes the gripper by controlling the motor via the rotary potentiometer. So the potentiometer actually was moved, rotated, and that actually rotated the motor at the top of the system, and the motor was connected to a gripper through some gear mechanism, and then the gripper opening and closing was controlled by the potentiometer, and the electronics actually was inside the I think this plate. So this plate was used for the solar power. But for this experiment, actually, we did not use any solar power. That means it was not powered by the solar energy, but it was powered by the electric energy, because we did not complete that part. So currently, it did not power. That means we did not power our system or our electronics by the solar power, but it was powered by our electricity. But in the future, we have to replace it, because our objective was not to use electricity, but to produce
This
electricity
is a
from solar
gentle
power.
10 minutes reminder.
Okay, so then this is our experimental results. The experimental results were agreeable with our objective, and finally, also we did some human user friendliness test. We conducted the user studies, and the human subjects were asked about their perception regarding the heaviness and convenience of use of the system. So then these results show that the human perceived the heaviness as appropriate, and also human users perceived that the system was convenient to be used. So then, based on these results, so we are convinced that our system actually was partly successful. So we explained in this presentation, we explained the proposed design, and the design partly satisfies our requirements. So we will revise the design to further reduce its weight and size, because currently it is large and comparatively heavy, but we want to make it I think less heavy, and also we want to reduce the size in our revision of the design. We will conduct more experiments using many subjects to evaluate the overall performance of the device, and we will use objects of different sizes and shapes, so that it is a robust system that can be used for many different types of objects. And also we will power the electronics from solar energy. Currently, we are powering it from electricity, but we will use the solar panels to produce electricity from solar energy, so that it can satisfy our main objective, that it should be solar powered. So this objective has not been satisfied yet, but that is our next one. So I think this is the end of my presentation. So if you have any question and comment, I will be happy to answer your question.
Okay, first of all, sir, you have given very wonderful presentation.
Thank you.
And yeah, I have some question regarding your performance evaluation Okay, how you okay, can you tell me something more on the performance? How you measure the performance of your proposed?
Measure the performance, actually we partly measured it in our current status. We are not, that means it is just a prototype, working prototype. It is not a I think a real system that can be used by the normal users. So here, for example, we tested, we did 3 experiments. First, we tested the component level, whether the opening and closing, whether the movement of the potentiometer can actually move the motor in the same direction or in the with the same speed. So that was successful. That was our component level test. And for the experiment, for the system level test, so we actually tried to pick and place object by the healthy subjects. Currently, the subjects are healthy because we did not use any unhealthy or weak or sick people, because this is a different stage of performance evaluation that is slightly difficult. But we use the healthy subjects, and healthy subjects picked and placed object using this system, and the grippers were opened and closed by the potentiometer, and it was successful. So then it means that and the object was lightweight, maybe less than a pound, or a small object, because our current system cannot pick a very large object. So then it was successful. That means subjects were subjects were able to successfully pick and place objects. And it was not a manual control. It was actually controlled by the motor. So then picking and placing was controlled by the motor. So that was successful. So this is why we say this can satisfy the, I think, the performance requirement. And finally, based on the human subject's perception, we can say that it was perceived as not so heavy, and also it was perceived as convenient, so that we can get from the user study results. So these are the actual experimental results that can justify whether our systems are able to meet our requirements or not. But we believe that it can meet the requirements partly at that time, and it did not meet the requirements fully.
Okay, so good. And how you compare similar type of any component available, or you design this new thing? Is there
Definitely,
any similar component?
it is 100% new, but definitely there are similar components or similar devices available in the market or in the research literature. But in many cases, at the beginning, I mentioned that our work is different in the sense that it is not manual tool. It is an automated tool, or it is a robotic tool. It is not a manual reaching and grasping system. It is actually a robotic system. That is something new. And usually most of the current systems are manual systems. So it is a robotic system. First one. Second one, it has been controlled in a different way. For example, we are controlling it by the movement of the potentiometer, that is more human friendly, and that is more ergonomic. This is not a Swiss push button. It is actually a potentiometer, and that is more convenient for the user, because the user can control the amount of movement, amount of movement in their potentiometer. So that can help them pick different sizes of objects, and depending on the size of the object, the human can control the amount of movement of the potentiometer, that can control the amount of opening and closing length of the gripper. That is new. And also our plan is to power it by solar power. That is completely new, because the current systems are not powered by solar energy.
Okay,
Okay.
thank you, sir.
Okay.
Just one question, yeah.
Sure.
Any limitation of your tools?
Any limitation?
Limitation.
Limitation, definitely limitation. Currently, the limitation is that the weight is not so small. It is still, we believe it is heavy. So that is a limitation. And also it is limitation the length. So the length should be flexible. length of the system should be flexible so that people of different sizes can use it. So the weight is a limitation, the length is a limitation, and also the price. Currently it is of high price, but the price should be lowered. And also if we use the solar power, so then how long the solar power will be able to power the motor. So then every time they will need to charge it, the solar power. So if so there is a lack of sun, so then the old people may not be able to use it because it needs to be powered by solar energy. So if the weather condition is not favorable, so then this system will not be so useful. So that means weather is an issue. So then in the bad weather, so this tool will not be usable.
Okay, thanks. Good presentation.
Thank you very much.
Thank you, sir, for your wonderful presentation.
Thank you.
Sorry. Can you stop
Okay,
presenting?
so I have to stop share. Yes.
Yes. Thank you so much.
Mhm.
Moving forward, I would like to invite Ma'am Paulina Azuero to present her paper titled Evaluation of Data Balancing Methods for the Classification of Digital Mammography Images with Benign and Malignant Breast Lesions using Machine Learning. Ma'am, do we have you with us there?
Okay, hello everyone.
Hello, ma'am. I'll stop sharing so that you can present your presentation.
Yep.
Yes, it's visible. You can start presenting.
Okay. Hello, I am going to present about evaluation of data balancing methods for the classification of digital mammographic image with benign and malignant breast lesion using machine learning. Yeah, the aim general is to evaluate data balancing method for classification of mammograph with benign and malignant lesion using machine learning. Specific is process the image and apply different data relieving techniques. Okay, the breast cancer is the most common in women according to the World Health Organization. This because women generate estrogen and progesterone, which are the cells that cause this disease when they have an uncontrolled appearance. Then is mentioned that the pathology is the cause of thousands of deaths. For example, in Latin America, of 4 million people detected with cancer, but 4 million people died from it. It is therefore utmost important to detect breast cancer in its early stage in order to decrease the mortality rate. For example, in my country, Ecuador, breast cancer is most common. The most common way to do this to have mammograms, which are image of the breast to detect abnormality in the breast. But there will always be a discrepancy between the radiologists determined whether or not a patient has cancer. Therefore, in recent time, artificial intelligence has become a super powerful tool to help make decisions, but not to replace people, in this case, doctor. The problem with using IA is getting a big data set. Usually to perform experiments, we use a public data set, which don't have a sufficient number of samples to perform a train and test. In our case, so we have decided to perform experiment with balancing techniques. We use a public dataset. This dataset a total of 322 images, including benign, malignant, and normal. As can see in the sample image, most of them are benign images. Our module focus on apply different machine learning techniques, such as support vector machine, convolutional network, and other techniques. For this technique, we have applied normal, convolutional neuronal network, and transfer learning, and finally use balancing techniques to avoid bias when training the models. As can see, we balance the class, but when applying the balanced dataset, the results are not as good as when training with the normal dataset, and they are applying a bagging techniques, which take the prediction of two models. In this case, SVM and random forest. In general, performing bagging techniques is somewhat complicated since in generate image white noise that for use a human doesn't make sense to see an image generated by bagging techniques. Okay, conclusion and future work. The challenge of imbalancing medical image dataset remains crucial due to the complex of representing variability in the appearance of abnormalities. This work established a foundation for future research and propose new techniques to address this challenge. Machine learning has potential significant impact in this area, so we recommend adopting modern approach, increasing the size of datasets and promoting multiple efforts to accelerate progress. And future work is explored other AI techniques such KNN, SVM, and convolutional network CNN. Evaluate performance with the new dataset for broader and more robust validation. Conduct an exhaustive hyperparameter search the optimist model performance in terms of accuracy and efficiency. Thank you.
Okay, so you applied different machine learning techniques on these particular data sets. So can you compare their performance in between different machine learning techniques? Which is better, why, in which case, like that?
Can you repeat the question, please?
Okay, so I hope you applied different machine learning techniques on this particular data set. How you compare the performance between different machine learning techniques? Because you mentioned like support vector machine, k nearest neighbor, like, so how you compare the performance in between these different machine learning techniques?
Excuse me, I don't speak English. Do you write, please?
Can you tell me the novelty, contribution, your contribution?
Okay, we are do compare techniques or balancing because we have a small data set. So we apply different techniques to balance data set. But in this case, don't have a good result. So we apply a bagging to get a excellent result. In this table, you can see, for example, if I apply a CNN or SBM or other techniques, is have a good accuracy, precision, recall, F1 score. But if I implement CNN and smooth, that is a balancing technique, don't have an excellent result. So we apply a ensemble with bagging, SVM and random forest. We have the best accuracy, precision, recall, and F1 score.
Okay. Okay, thanks.
Thank you.
Okay. What the advantage? The advantage of your tools.
Do you say about tools?
Yes, the advantage of the tools. Can you explain about the advantage of your tools?
We use a mammography image. We use a public data set. These have a small, or these have a small data set. For example, this have a 322 image. So these are a small data set. This name is mini MIAS data set of mammograph.
Okay, thanks.
Thank you.
Thank you, ma'am. Can you please stop sharing? Yes. Thank you for your presentation, ma'am. Uh, just a second. Moving forward, I would like to invite Sir Carlos Remis to present his paper titled Internal Flow Model of a Helical Centrifugal Atomizer for Cold Preservation Systems in the Fishing Industry. Sir, do we have you with us?
Hello.
Um,
Yes, please
yes,
let me a second to share my presentation.
yes, please. Yes, it's visible.
This
You
is
may
visible?
start now. Yes.
Okay. Sure. Okay. This is okay. Okay. This is one of my first presentation. The paper for this occasion is a structural model for hydrostatic cryogenic liquid storage and pressure tank in the food sector. This project is oriented in the Food and Agriculture Organization nations that indicate that fish deterioration begins as soon as it dies, which implies that the proper handling and rapid refrigeration are essential to maintain its quality. However, the use of ice in fishing vessels presents significant challenges, essentially in tropic and subtropical regions. For this occasion, we proposed a solution about in the cooling system logistic and the associated cost, the use of cryogenic fluid in proposed to prevent the fish deterioration. Cryogenic fluids required extremely rigorous storage and handling conditions, This is the reason that we need to conduct high pressure tests with these fluids in maintaining on multiple locations without compromise safely or efficiently. This is the idea of our project. In this presentation, an analysis of the hydrostatic tank, that was one of the elements that we developed during this project. We maintain the fluid temperature, preventing thermal exchange with the environment, and it designs incorporate the safe valves, mobile flies, has also been considered a key factor. This is the idea of the tank. We have the implementation phase diagram. This is the different components. We need to work with fluids at high pressures. In a thermal insulation storage device was designed first, where it incorporated into the base design and facilitate its mobility. This is the tiles here. It was proposed that the tank have an upper inlet throat with high pressure gas could be introduced, and thus fluid will exit through a lower conduit. In this way, the pressure effect is utilized according to the Pascal theorem in order to prevent the transfer of temperature between the fluid and the environment. It is specific that the tank should consist of two departments separated by polyurethane insulated material. That is the here, the gray zones. In this transmission channel function as internal support, which help reduce any heat transfer between the external environment and the interior of the tank. This is one of the components when it was development, the valves that define the pressure of the heat, and also during the construction, we can view the tank with penetrable test, where the element and test we do during the construction. The hydrostatic test involved filling the container with a liquid, usually water, and then pressurizing it to a level higher than its normal operating pressure. The goal is to ensure that the container can handle the operating pressure without any leaks of damage. Was one of the tests. Where are the sensors for hydrostatic tension? The calibration of the pressure gauge and thermometer using the hydrostatic pressure test was carried out. In the case of the thermostat, a recalibration was performed using the direct comparison method. These are the values that we obtain after the test. And with as a conclusion, we can use the double enclosure design inside its greater extent of the heat transference from exterior to interior enclosure. The implementing of a design with multiple transmit challenge allow for better management of a storage tank during operation. They also serve as internal support. The correct tank design and fabrication enable it to without a stand hydrostatic pressure test of 225 psi for approximately 2 hours. There is a higher probability of a storage failure due to the valves of sensor end to the tank. The validation of manufacturing design suggests that the use of various steels will allow for proper freezing of foods and meeting required hygienic standards. And it is imperative to have the necessary tools on specialized knowledge in order to ensure integrity, and manufacturing process. Okay, thanks a lot. This is the first presentation.
Okay,
Thank you,
so
sir.
can you tell us the challenges you face? Challenges.
Yes, it was really many of one, but the first of all was the test after the design. No, we use some programs to do tests to the design for simulation previously. It was we have a good idea that it was a good design, but when we development the tank and test it in the practice, it was really better to ensure that the previous tests simulated were the appropriate. This was the better challenges.
Okay, thank you.
Thanks a lot.
Any weaknesses about your tools? The weaknesses.
Excuse me.
Any the weaknesses about your tools?
About the tools, in our case, we use ANSYS software. This was the tools that we use to simulate the design using the CFD program or modules from ANSYS to to test previously to the design phase this project. This was the tools that we use.
Okay.
Thank you, sir,
Thanks.
for your presentation. Um,
I have another presentation.
that is in the end, sir. I would now like to request Sir S.M. Mizanur Rahman to kindly present his paper titled Modeling and Analysis of Dynamic Smart Solar Panel System for Harvesting Solar Energy in Remote Areas.
Thank you. So, yeah, so then I will share it now.
Yes, sir, your presentation is
Yeah,
visible.
so okay. So, thank you. So this is my second presentation. The topic is modeling and analysis of a dynamic smart solar panel system for harvesting solar energy in remote areas. So, and this presentation is completely different from my previous presentation, even though both presentations tell about solar energy, but I think the objective of this presentation is totally different from that of my previous presentation, and the content is also different. But in both cases, I am dealing with some solar energy problems. So then, background and motivation. So, you know that solar energy seems to be the most reliable source of energy for powering agriculture in remote areas where electricity supply is difficult. So we have many remote areas in different countries where electricity is very difficult. This is why solar energy may be a great source of power to power agriculture, for example, irrigation and greenhouses. So powering irrigation and greenhouses for agriculture in remote areas where electricity is very difficult may take benefit from solar energy. So, however, and considering this requirement, researchers are conducting research on solar energy, and they are trying to propose different mechanisms of implementing solar panels to collect power from solar energy. However, currently the solar panels are stationary, but the sun is dynamic. That means the solar panels are stationary, but the sun is dynamic. As a result, the sunlight cannot heat the solar panels properly because sun is moving, but the solar panels are not moving. So as a result, we think that the sun cannot heat the solar panels properly, and as a result, we think that the solar energy harvesting is not able to produce maximum energy from the current system. So considering this problem, so there are several methods to make solar panels dynamic, tracking the sun. So one of the method is to use a light sensor on the solar panel. So it can sense the light of the sun, and then based on that, it can help the solar panels rotate with respect to the movement of the sun. However, this method has some limitation because the light sensor can only sense the light, but it cannot sense the direction of the light. This is why when the sun moves, so then if the light does not hit on the light sensor, then the sensing result will not be so accurate. So then it is also not a good system. So we think that the most efficient method seems to be making solar panels dynamic, tracking the sun. That means the solar panel will track the sun movement in some way, and then according to the movement of the sun, the solar panel will also move. So that will maximize the solar energy power harvesting. So to address this concept, so we actually in this presentation we want to focus it, and also there is another issue that we need to analyze the dynamic characteristics of the system before we build the entire system to predict its behaviors during prospective operations, because it is especially necessary when making solar panels dynamic, tracking the sun, because there are environmental disturbances such as rain, wind, snow, sands. So these type of disturbances can impact the dynamic loading condition or the dynamic operations or the dynamic characteristics of the solar panel. So it is better that we analyze the dynamic characteristics of a solar panel design and try to understand or try to predict the dynamic behavior of the system before we can make it. So without having such dynamic characteristics analysis, so if we make a dynamic solar panel system tracking the sun, so it may not be able to cope with the disturbances during rain, wind, snow, and sands, and it may not be dynamically stable. Especially it is a challenge when the solar panel systems become very large and heavy. So then we need to do some analysis to understand the dynamic characteristics of the solar panel. However, the current projects with the solar panel systems do not show the dynamic characteristic analysis modeling. So that is a limitation of the current research. So to address these limitations, so our objective is to investigate the difference in energy harvesting between a static solar panel system and an arbitrarily designed dynamic solar panel system, and to propose a model of analyzing dynamic characteristics for a solar panel tracking the sun in real time to best predict dynamic characteristics of the rotating solar panels so that the maximum energy harvest is possible. So what we did, so we developed a prototype of the solar panel. So this is a solar panel prototype. This is very small, but it is still okay. So we have two panels here. So then we have two motors. One motor can can control I think that the inclination. Inclination means whether it will, what will be the angle of the solar panels with respect to sun. The inclination can be controlled by one motor, and the rotating of the solar panels with respect to sun can be controlled by another solar panel, another motor. So then the lower diagram can show how we can attach to servo motor through the Arduino board and the shield board. So then servo motor 1 and servo motor 2 can be connected to Arduino board and the shield board, so that we can control. And also we can connect each solar panel with a solar controller and a battery. So then the solar panel will be heated by the solar sun, and then the solar charger or the solar controller can convert the solar power into electric power, and a battery can be attached to the solar controller, and that can be used to store the collected energy in the form of electricity. So then this is our prototype we developed. After that, we conducted a system model. We developed a system model. The first diagram shows that a system model using different domains. So this is the system model, and we have an equation of motion, that is equation 1. And based on the equation, we derive the transfer function so that we can do some dynamic analysis with the system. And once we have the transfer function, that is equation 2, that came from equation 1. So then based on the transfer function, we try to develop different types of dynamic response plots. For example, a step response plot. So we had different iterations. So in the first iteration, we did not get good results. In the second iteration, we got slightly better results. But in the third iteration, we got, I think, further better results. So in the third iteration, this step response curve shows that for a particular set of values of the system parameters, so then we see that the step response curve shows that the overshoot is not so high, though it has some overshoot, but the overshoot is not so high. Also, the settling time is not so high. So we think that this can be a good response. So then based on this response, we selected that values of system parameters that can be used to design the physical prototype. And also we conducted other different types of analysis, for example, impulse response. So impulse response can also help us understand how the system will be able to adjust with any impulse force, like sudden force due to snow, due to wind, due to storm. So how it will impact the dynamic system, dynamic behavior of the system. So the impulse response shows that it will settle. It will be able to cope with the impact of the dynamic loads, but it is slightly slow in the response for the current system parameter values. So we need to change the values to have a better one. And our root locus method shows that the system was stable for the current set of values of the parameter, because all the roots are in the left side of the system of the root locus plot, that shows that the system was stable. And also we have another body diagram that also shows that the system was stable for the current set of values of system parameters. So then we also have the Nyquist diagram that can also show the system stability. So finally, then once
This
we
is a
were
gentle
happy
10 minutes reminder.
with the simulation results, then we conducted 2 experiments. And the first experiment was that the solar panels remain stationary. Then the solar panels rotate slowly with respect to the sun based on an arbitrary speed for a fixed period of time. And we collected energies from the solar panels, and then we stored energies in the batteries. So the amount of energy stored in the batteries can tell us the ultimate output of the system. And then we have the plot. So this plot shows that the solar panel voltage or input voltages and the associated battery voltages or output voltages for the rotating solar panel system. So they at different times. So we started our experiment at 8 a.m. and the trial was 30 minutes. Then it ended at 10:30. Then we have couple of trials, 1, 2, 3, 4, 5 trials, and each trial was 30 minutes, each trial of 30 minutes duration. And then this shows the batteries, the voltage that we collected in the batteries from the solar panels. So then we have another experiment that shows the solar panel voltages and the associated battery voltages for the stationary solar panel system. So then we can compare these two tables. That means the energy harvested for the stationary solar panel and the energy harvested for the rotating solar panel. So then we see that there is some difference. That means there is some improvement in the energy harvesting for the rotating solar panel system over the stationary solar panel system. But however, the increment or the improvement in the energy harvesting was not very high, or it was not as expected, as high as we expected. The reason may be that we were not able to determine the appropriate speed of rotating the solar panel. We believe that our speed
Sorry
was
to interrupt,
not
sir.
okay. Thank you. We have 2
Uh,
minutes. So the speed was not appropriate.
no, I'm sorry, sir. I gave you a 10 minutes reminder earlier. Can you
Okay.
please conclude the presentation
Okay,
because
thank
it's
you. So
like fast?
then we are done. Actually, we investigated the difference in energy harvesting between a static solar panel and an arbitrary designed solar panel. And we proposed a model of analyzing dynamic characteristics for a solar panel tracking the sun in real time to best predict dynamic characteristics of the rotating solar panel. And the objective was to maximize. And in the future, we'll use a machine learning concept to learn the appropriate speed of the solar panel that can be able to best predict the speed of the sun, and so that it can track the sun in the better way. Yeah.
Okay,
Yeah, and
yeah, so you made the rotating solar panel system. So I think
yes.
there is some major problem with the solar panel system is the cost. Okay, so
Mhm.
in rotating panel system, I think it's required more electricity. So how you can give the some your comments on this the cost.
Yeah, definitely. It will be expensive because the rotating, it is not stationary, so we have to rotate. That means, and this system that I developed, this is a very small system, but the practical system will be very heavy, so it will take huge amount of power to rotate it. So at the beginning, the power will come from some generator. After that, once we will be able to produce enough amount of solar energy, so then that can be used to rotate the solar panel system in the second stage. But I think the power that will harvest from the solar energy, a part of the power will also need to be used to rotate the solar panel. So we have to calculate the benefit and cost. But as it will maximize the production, then I think the cost will be justified.
Okay,
Yeah,
thank you, sir.
yeah. Thank you.
Thank you.
Thank
No
you.
question from me.
Okay, thank you very much.
Okay. Thank you for your presentation, sir.
Mhm.
Uh, I would now like to request, uh, just a second. Extremely sorry. Um, okay. Yes, I would now like to request ma'am to kindly present her paper title, Modeling of Models and Processes that Differentiate Semantically Polyfunctional Words in the Context of Uzbek Language. Ma'am, are you here? Ma'am Emlova Zolism. Uh, I'm sorry if that's the correct pronunciation of name.
Thank you very much. Yes, I am here.
Yes, ma'am.
Our
You can kindly
article.
start the presentation.
Thank you. Our article's name is Modeling of Models and Processes that Differentiate Semantical Polyfunctional Words in the Context of the Uzbek Language. The problem of polyfunctionality of lexical units is one of the argument problems
Sorry
of
to interrupt.
modern.
Sorry to interrupt, ma'am. Your presentation is not visible. Yes, it's visible now.
Thank you. Polyfunctional words are an element of word sense disambiguations. Polyfunctional words are words that have the same form and meaning within the same topic. They can be distinguished by having answer to questions of different words group in different sentences. The problem of polyfunctionality of lexical units is one of the urgent problems of modern linguistics. The issue of polyfunctional words is often found in Russian, English, Tatar, and Chinese language in world linguistics. The concept of polyfunctionality appears is some source in the form of multifunctionality in many foreign language works. Polyfunctionality is considered in connection with the phenomena of homonymy. Example of polyfunctional words in English are pronouns, provided that the modal word able can be considered as a polyfunctional word with the help of annotation. Discussion polyfunctional words form 21 groups in the Uzbek language according to their occurrence within part of speech. Noun or adjective, or adverb, and etc. Determining polyfunctionality between noun or adjective word groups, we take the word kasal, it's ill in English, as an example of words that creates polyfunctionality between noun and adjective. Here are some examples of how the word kasal is used as a noun in the context and when it is used as an adjective. In sentence, first and second, the words castle belongs to the noun groups. In next, third and fourth words in castle is the adjective. In this sentence, this is model determining polyfunctionality between noun or adjective words group. Their PF is polyfunctional words, meaning PF noun, this meanings, this polyfunctional word is noun. The next, determining polyfunctionality between adjective or modal words group, we define the mathematical model defining the polyfunctional between the adjective or modal words groups using the exact words and conclude. There, this mathematical models mathematical model is determining polyfunctionality between adjective or modal word groups. There are the first mathematical models independent verb and auxiliary verb The second mathematical model determines the polyfunctionality between adjectives and adverb. The third mathematical models is determining the polyfunctionality between the conjunction or auxiliary verb. To correctly define polyfunctionality, it is necessary to distinguish the set of words that can be combined with these words. In short, a large amount of context is necessary. With enough context, models can be tested. There are a number of models of information systems, for example, information models, conceptual models, models of representing business process in the system. In today's article, we describe the processes that determine polyfunctionality in the system. A number of notation can be used to model business process, UML, IDF3, and BPM notations are among them. One of the modern notations in business process modeling is BPM notation. The following business process are modeled using this notation. In this, there are the information system of semantic analysis of sentence in the Uzbek language perform general process as shown is shown in this picture, and each complex process includes several sub-processes. In this picture, we can show sort process determining of polyfunctionality. That process of determining how many parts of speech polyfunctional word belong to. First, checking that the polyfunctional word sequence number is 2 or 3. It is known that polyfunctional words in Uzbek language are found within 2 or 3 parts of speech. In the Uzbek language, polyfunctional words within 2 parts of speech are divided into 15 groups. The process of determining polyfunctional within 2 parts of speech. The process of determining polyfunctionality within this is 3 parts of speech. There are 3 groups. Information system architecture. The main goal of the article is to distinguish polyfunctional words, which are one of the elements of semantic analyzer of the Uzbek language, based on the above mentioned business process, based on mentioned mathematical models and algorithms. We believe that we have approached the goal before developing an information system for semantic analysis of sentences in the Uzbek language. It is required to develop its architecture, structure, and conceptual model. This information system was developed based on the Django MVT model view template architecture. Must in this picture. The next, the structure of information system. There are software, information supply, technique supply, organization, morphological support, mathematical supply, and linguistic supply. In linguistic supply, there are semantical words, polyfunctional words, phrase, words, a collection of text in the corpus, and etc. Includes in linguistic support. In this, there are conceptual model of semantic analysis of sentence. There are front-end parts and back-end parts. The next feedback part. The role of polyfunctional words in the development of the information system for the semantic analysis of sentence in the Uzbek language is significant. Polyfunctional words in the Uzbek language can be determined using method based on your basic rules for semantic differentiation because they differ in morphological characters. In order to differentiate polyfunctional words in the Uzbek language in context, connection between words words are of course of great importance. We 500 sentences were entered into the developed information systems as a test. The number of exact results obtained from the entered sentence was 359. Overall, 71% accuracy was achieved. It is advisable to use machine learning and artificial intelligent methods to further increase efficiency. These connections are called grammatical connection in Turkic language. Semantic analyzer are developed using the interaction of words in a sentence. Thank you for your attention.
Okay, so your accuracy is near about 71%. So can you tell me how you test your system?
Thank you. We in information systems we tested process the number of results 50 sentence we are entered into the information systems, and our exact result was 359 sentence. It's we checked by humans. We use it in this test. We use linguistic personnel. We use it in linguists.
Okay, and is there any similar kind of system is available for the same thing? If yes, then how you compare your result with existing?
Excuse me, repeat it once more. I didn't hear.
How you compare your result with existing?
We complete help of professional linguist professionals. We use it their help.
Okay. Okay, thank you.
Thank you.
Thank you, ma'am, for your presentation.
Next presentation.
Yes. Just a second. Okay. I would like to request Sir Carlos Raymond to kindly present his paper titled Structural Model of a Hydrostatic Cryogenic Liquid Storage and Pressurization Tank in the Food Sector. Sir, are you there?
Okay, please let me let me share my presentation.
Yes. Your screen is visible, sir. You may start.
Excuse me, just a moment. Okay, this is the second paper. In this case, let me show the second part of the project. This is an internal flow model for helicoidal centrifugal atomizer for cool preservation system in the fishing industry. This is the second part of the project specifically. It's similar to the project, is part of the same project, but this is specifically the atomizer. This is the design of the atomizer with a square pressure nozzle for generation of atomized particles. In this case, of the water is presented. This device has the development of as a part of the methodology for creation in the centrifugal fluid atomizer, in which water is mixed with cryogenic fluid in order to generate atomizer particles to facilitate the preservation of the aquatic food. The principal idea of this project is to generate ice in the sea. This is the goal of this project. One of the principal problems in the fishing industry in the fishing industry here in Peru is that it is most common that the infrastructure for the fishing industry is that they need to take the ice since its departure. The idea of this project is to generate the ice in the sea. So with this project, we try to resolve some of the problem of this industry. One of the elements of this is the atomizer, the cross section. We can see that the water is introduced, but also the other element like the nitrogen, the liquid nitrogen is also inserted, and it's mixed and generate the particles of ice that this is necessary for this kind of industry. The inner atomizer is intended to work with cryogenic fluids as a component of an section for the cryogenic liquid, a swirl generation price, which contain helicoidal channels with an inclination angle and its corresponding vortex chamber, where the cryogenic fluid will exhibit rotation behavior, ultimately producing at the outlet a fine atomization or conical spray. It is the word of nothing that the helicoidal channel have a rectangle cross section which facilitate the manufacture process into computer controlled CNC lathes. For the validate of the project, we developed the atomizer, and we validate the design using consideration for the tangential distance, an angle of a delta will take an exact value of 0. Finally, thanks to the imminent collision of the both sprites, fine atomization is achieved. This is the geometrical construction parameter that we use. And finally, the behavior of the mixes of the two liquids, the water and in our case, the the liquid nitrogen generate the ice. First, a three-dimensional mesh of external elements was created using ANSYS. This is the software that you used for the design that permit us to simulate and understand this type of optimization. This is the hexagonal mesh of the liquidal channel that we use. And secondly, a primary simulation of is presenting an liquidal index atomizer with ANSYS Fluent. This is the version 2023 software. Consider the appropriate turbulence model of the liquid behavior. This is this is the simulation that we generate. We control the pressure of not only from the water, also from the liquids of the nitrox to generate the exactly conditions to generate the ice. The conclusion, the manufacture of the atomizer is feasible through the use of 3D modeling tools. Manufacturing the liquidal channel is in a rectangular format allows for a simpler machine and therefore low cost. The design of atomizer was reducing dimensions, which facilitate handling by operators in the food industry. This device can operate with a variety of fluids at a high pressure and various temperatures for atomization purpose, not only in the sea industry, also, for example, in the food industry is also required. Using ANSYS simulation software, the working capacity of the design atomizer is verified by employing the respectively dimension and implementing an additional safe system use cover made of polyurethane material to encase the creative fluid will help to mitigate risk. Thanks a lot.
Sir, actually, I have one query. I think this PPT title is not matching with the paper title that we have showed in the flyer. So, is it related to the paper or is it a different PPT?
Excuse me, I didn't hear exactly.
Yeah, the paper title is Structural Model of Hydrostatic Cryogenic Liquid Storage and Pressurization Tank in the Food Sector. But the title here in the PPT is different from the one that is in the flyer.
Well, yes. The idea is this is a case of study that we use for this kind of industry, but the design is open for many other case of study and many other liquids, other cryogenic liquids.
Okay, sir. So is it same as the previous one or they both are different papers?
Usually for the first the lab experiment we use water with liquid nitrogen, but also when we are going to introduce this instrument in the sea, we are going to try to use seawater in order to don't need to transport it in the in with the ball. No, this is the idea. This is another phase of the project.
Okay, we can begin with the question and answers round.
Okay, only one question from my side. How you test your system?
Excuse me?
Performance of your system.
Uh, well, in our case, it is a project that we select because it's a important industry here in Peru. That was the idea to select the project. And the element that we have principally was uh, the precision of the tubes. This was because it's millimetric, so it was first design and simulate previously to the development. But when were trying to implement, it was one of the best challenges to do it. We need to redesign our many elements in order to implement it with a low cost development, because maybe we couldn't implement the element, the atomizer, but maybe the cost will be high. The idea were to have a design that could be a low cost implementation.
Okay, thank you.
Thanks a lot.
Thank you, sir, for your presentation. Are
Thanks.
there any other questions?
No, thanks.
Okay. Sir, can you please stop presenting? Thank you, sir. Uh, I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough, and we, on behalf of the whole team, thank you for the support during the ninth version and all the previous 8 versions of the conference. We will be happy to have you in the 10th version in 2025 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to this printer. The publication will be live within 6 months. I kindly request everyone to cooperate with the team of ICICT 2024. I also thank our session chairs, Professor Deepak Mane and I'm sorry, Professor Deepak Mane and Professor Eka Nurul Kumari, uh, for chairing the session. Thank you, sir and ma'am. A token of appreciation to the chairs on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable time and presence. I kindly request you all to switch on your cameras for a quick snapshot of the virtual conference.
Okay, thank you.
Just a minute. If everyone can open the cameras. Yes. 1, 2, 3. Thank you everyone. Stay safe, stay connected. Bye bye.
Bye-bye.